Hello, and welcome back to Math with Sensei Brian. I'm Sensei Brian McWashington, your math host, your math sensei, your math teacher, your math partner, whatever you want me to be. Sorry it took so long for this video, but things have happened and things have transpired that are beyond my control. But that's a thing that we call life. Before I get started, I have to say this. You'll notice two names up here, and you'll notice the end dates are 2020. This has not been a good year for a lot of people. It affects Sensei too. This was my wife, Candace Butler. She died of COVID in July of this year, just a week after my birthday. No bueno. COVID is real. Please take care of yourselves. Please do what you need to do to stay safe. Okay? Please. And this is November of 2020, so this makes the 4th month. This is the reason it took me a while. That's my father, Edward P. Brown Jr., 83 years. He is very responsible for the man you see sitting in front of you. The reason I'm an electrician, I wanted to be like my dad. The reason I know math is because my father taught me before I was 2 years old. The reason I'm the man you see sitting in front of you today is because of this man. The musician I am is because he got me started. Always remember, life is short. That's why I tell you to be kind to everyone. You never know. 83 years is not a long time. And if you think I'm being a little facetious about that, a tree can live 400, 500, 600 years. What's 83 years? But what you leave behind, this is my gift to all of you. This is what I leave behind. You always hear me say, math has been here before us, and it's going to be here after us. So we might as well get acquainted with it so it's not such a stranger. Okay. Now that that's out of the way, fractions. This is going to be such a monumental video. I'm going to have to split it into 2 parts because fractions are more than just what you see. We'll get into that a little bit later, but let me get you started on the basics. An incremental part of a whole number. Okay, but isn't a decimal basically the same thing? Well, what's the real difference? As you'll find, a fraction is sometimes an approximation or a close guess to a whole number or a part of a whole number, as we're going to find out. So, I'm going to once again draw a beautiful, beautiful pie, whatever flavor you like. If you don't like pie, call it cake or brownie, whatever you want to call it, right? But either way, you have one thing that's broken into 4 things, or parts of one thing. So the denominator or the bottom number is the number of parts needed to make complete or whole. So you have 4 parts, right? That's what the 4 represents. The numerator is a 3. How many parts of the whole you actually have? So you have this here, 1, 2, 3. So in effect, you have 3 out of 4 parts of that, or 3/4 of that, or as we say in the United States, 3/4, right? 3/4 can be written as a decimal, which we'll get into later, okay? But just know, initially, that's what these 2 parts mean. 3 out of 4. It's also a ratio. You have 3 out of 4 of these parts, so 3 out of 4 of these parts are shaded, right? For every 4 parts, 3 of them are shaded. That's a ratio. We'll get into that later. Right now, I'm going to play Mr. White Clean. Just as I promised, it's White Clean. Now, let's get into fractions, okay? So, I'm going to draw 1 pi here. I'm going to draw 1 pi here. I'm going to draw 1 pi here, and I'm going to draw 1 here. Right? I'm going to do this. Okay. You have something broken into 2, right? 2 parts. So now you have 1 out of 2. You have something broken in 3. Now you have 1 out of 3. You have something broken into 4. You now have 1 out of 4. You have something broken into 5. You now have 1 out of 5. You have something broken into 6. You now have 1 out of 6. That's kind of explanatory, self-explanatory, right? Or explains itself. The denominator, how many pieces you have to make the whole. You have 2. I shaded in 1. So you have 1/2 or 1 out of 2. You have 3 parts here. The denominator is 3. I've shaded in 1. You've got 1 out of 3. And 4 and 5 and 6. Kind of self-explanatory. Okay. Well, you say, Sensei, why do we worry about this? What's so great about fractions? Well, okay. Supposing you have 3 kids, right? And you have 1 chocolate cake, right? You want to divide it into 3 equal parts. Not exactly equal, but you have 1/3 here, 1/3 here, and 1/3 here. Each kid gets 1/3 of it. That's right. So it's like this. Right? So you have 1/3 plus 1/3 plus 1/3. 1 plus 1 plus 1. I'm going to actually do it this way. That's better. You have the denominator does not change. When you're adding or subtracting. Ooh, error number 1 for the blooper reel. When you're adding or subtracting, the denominator stays the same. So we add the numerators. Now I have 3 of these. Now there's 1. 3/3. Anytime, remember I told you, anytime you have one number over itself, it equals the number 1. Right? Ooh, the multiplicative identity is 1. See how all this comes into play? Now, let's say, well, gee, Sensei, what happens if you have a number bigger than the one on the bottom? Let's use them thirds again. Let's get a number like this, 5/3. Well, remember I told you if you come up with something like this as a final answer, it's not wrong. But in the early stages of math, they're going to call this improper. I am proper fraction. Because the numerator is bigger than the denominator, it's considered improper. Along that line of thinking, the numerator should never be bigger than the denominator. So, how do we make this proper? Well, how many parts do we need to make this a whole 1? If you said 3, you got it right. So, how many 3s are in here? Right? You have 1. Boom. How many are left over? 5 minus 3 is what? There's your final answer. Okay? This is what early teachers are going to want to see in math. This is what they're going to want to see. This is not a wrong answer. But if you're in like 2nd, 3rd, or 4th grade, your teacher might ding you for it. But just know as you get higher in math, to have this is not a wrong thing. Okay? Well, I'm going to show you how I did it again. You have 3 parts to make this whole. So you got 1 whole out of that, right? How many parts do you have left over? 5 minus 3 is 2. That's how we do that. Well, what if you have a bigger number, Sensei? Let's use that 3 again. Let's say, right? So, now you got to do some multiplying. How many 3s in 14? So you can do it this way. Right? 3 goes into 14. 4. 12. Now, remember when you started math, you see this? 4 R2, not R2D2, remainder 2. Guess what? That's what that R stood for. You have 2 left over. Okay? Early in math, you'll see remainders. Well, that remainder goes up here on top of that. Oh, it's not that hard, is it? Tell you this stuff is easy. And you're catching it real good. Thank you. Now, let's add fractions. Oh, okay. How do we add this? Okay. When the denominator is the same, you just add the top numbers. Okay? 3 plus 6 is what? 9. Real simple. Okay? Now, let's see what happens when the bottom numbers are different. Let's do this. Okay? Since we're talking algebra, let's give it a letter. How do we do this? There is a term called LCD, least common denominator. Least common denominator, or LCD. What does that mean? Well, to find the LCD, you have to find what this and what this goes into. That's the smallest number. Okay? What does 3 and 4 go into evenly? Well, because they're so small, does 3 and 4 go into 6? No. 8? No. 9? No. 10? No. How about 12? Let's see. You do it over here, you got to do it over here. Now, 3 goes into 12 how many times? 3 times what is 12? 3, 6, 9, 12. 4, right? So 4 times 2 is what? 8. 4 goes into 12 how many times? 4, 8, 12. 3 times, right? 3 times 3 is 9. Ah, see how I did that? This makes it a little easier for you to do, right? Or you could have wrote it in parentheses. It doesn't matter, right? The number you know you got to multiply by, you can just write it small right next to it so you can see it, okay? That's just an easy way I came up with. I probably know I didn't invent this because math has been around 150,000 years. So, but nonetheless, if this method helps you, please use it. 8 plus 9 equals, okay. Now remember, since you're early and you're learning this, you got 112 in here, right? Because 12 goes into 17 one time with how many left over? 13, 14, 15, 16, 17. And ladies and gentlemen, there we have it. That's how you add fractions. But I'm going to give you a kicker. To subtract them, you do the same thing. If I was to make this a negative number, let's do this. Let's subtract. You still do the same process. Wow, how do you have a negative fraction? So 8 minus 9 is what? Negative 112? Sure, you can have that number. Nothing wrong with that. You can have a negative fraction. Sure you can, because it's a negative number. You can have a negative fraction as a final answer. So don't think it weird when you see it, okay? The 4 functions. We just covered this. We just covered this. Now, let's multiply. Let's go. No, I'm going to show you something real quick. Now, before we go on with this, I'm going to tell you, you just multiply straight across. But before we go on with this, I'm going to teach you how to do something real quick. Let's forget about this number for a minute. What's special about this number? You should see it right off the bat. 8 and 10 are even numbers. Anytime a number is even, it is divisible by. So what we're going to learn to do right now is reduce this fraction to the lowest terms. Okay? 2 goes into 8 how many times? 4. 2 goes into 10 how many times? 5. Okay? You got one side. Well, look at this. It's the same thing. But instead of dividing by 2, what number goes into here? 3 goes into here, doesn't it, right? 3 can go into 6 and 12. But guess what? So can 6. 6, 12. Now, one thing you can do, and one thing you should do, is if you can reduce a number before you multiply it out, it makes it a whole lot easier to get to the end. 10 times 12 is 120, right? Watch this. 8 times 6 is 48. Watch this. 4 times 1 is 4. 5 times 2 is 10. Can I reduce this? I most certainly can. If I divide this whole thing by 2, 4 divided by 2 is 2, right? 5. That, my friends, is your final answer, right? Well, guess what? If I did the same thing here, if I reduce this number by 6, I can reduce it by 12 as well, because 12 goes into 48. How many times? Actually, I can reduce it more than that. I can reduce it by 24. 24 goes into 48 times 2. Well, glory be. Isn't that the same number? That's because it's even. That's reducing fractions. Some teachers will teach you to reduce it early. You don't have to deal with a big number like this. You just dealt with this. And it's easier to reduce than to come here, because you could be sitting here all day. Well, Lord, 2 or 4 or, 8, 12, 24, 40. Okay, see, that takes time, right? So, try to reduce your numbers before you do anything else, if you can, if it's permissible. Sometimes it's not, but if you can do it, reduce it, okay? But that's how you reduce a fraction. If a teacher tells you to reduce this number, right? Right? What number goes into 6 and 9 evenly? 3 goes into 6 twice. 3 goes into 9 3 times. There you go. That's how you do it. Simple. 3 times 6. 3 times what is 6? 2. 3 times what is 9? 3. Okay. That's reducing the fraction. Makes your life easier. Now we've multiplied. So that only leaves division. Okay. Ooh-wee. So if I go 3/4 divided by 7/8. Well, that's kind of funky. Yes, I said funky. That means it stinks. Because the rule in mathematics is we really truly do not know how to divide fractions. So you might see it written as this. Or which is the same thing. Remember when I did that early on when it came to fractions? Early on when I did it early on in our earlier video? Okay. Well, you really don't know how to do this, so what we do is you go this is the reciprocal of that. You flip the number over and you multiply. So 3 times 8, my friends, is what? 7 times 4. Oh my goodness. What number goes into 24 and 28? Obviously 2 does, but we can go a little bit larger. Try 4. There you have it. It doesn't get any simpler than that. It doesn't get any simpler than that. Whenever you multiply, or whenever you divide fractions, you flip that bottom number over, you flip this number over, you multiply by the reciprocal. And you multiply across just like you always do. And then when you get to the end, you reduce the fractions. I'm at 21 minutes, okay? This is the first part of this video. You just learned how to do the 4 functions when it comes to fractions. We've added, subtracted, multiplied, and divided fractions. And I've given you an overall definition of what they are. In my next video, which will be video 6B, I'll show you what else we do with fractions, what other functions they hold. Okay? I'll also show you how to turn a fraction into a decimal. And when I said, well, why does it seem like it's an approximation? You're going to find out. God bless you, and I'll see you in the next video.